As you can see, I'm no stranger to multimeters. In fact, I've even built one up from a kit. This is my venerable Fluke 77, a classic, and that's been with me since the early 90s. We have a Fluke 11, always with a dodgy display, and something more up to date. Of course, when I started out in my electronics career, this was the Rolls-Royce of multimeters, and indeed my pride and joy at that particular time. Horrendously expensive, extremely heavy, and don't even think about dropping it. Today though, a new kid on the block. This is the Kaiweets KM601. Comes in this handy protective carry case and sports this very nice colour LCD display. We'll be able to see that in more clarity when I've adjusted the lighting. Let's now then take a closer look at this guy and see what new features it brings to the table. I really like this colourful LCD display. It does have a protective cover on there, and I'm not going to remove it. It'll be additional protection, and the screen is nice and clear even with it on. As we saw, it comes in this quite solid carry case. That's a big advantage too. I'm guilty, like many others, of just throwing a meter in a drawer after using it, and inevitably it gets the display all scratched up. This case then should keep everything nice and new looking. A nice set of leads then, feels like good quality cable, and the ends there can be removed. Obviously, if you're working in tight spaces, it's better to have that on there to avoid shorting anything out. Another nice touch is the removable protective plugs there. Also in the case, a spare set of batteries. I checked the date on these, they're 2024, so at the time of viewing, plenty of time left on them. And finally, a thermistor temperature probe. Turning to the meter itself then, the connections for the cables on the bottom there. As we will see, there is a range of LEDs underneath these to indicate to you which of the sockets you need to connect if you're unsure or just learning. That's a very useful feature. It comes in this very tough ruggedized, like one of those sort of ruggedized mobile type cases, and you have to remove that to get to the batteries underneath there. And when we look on the back, there is in fact an inbuilt torch function. That's nice and bright. How many times have you been under the stairs or in some cable cupboard in the dark trying to balance your torch or flashlight at the same time as using the meter? Very handy little addition there. On the top we have the main power switch, and this here, which is a sensor for non-contact voltage sensing. We'll take a look at that. Finally, on this side here, the APO is the automatic power off. The indicator here shows us that it's going to automatically power down after a few minutes. If we switch that off, we're not in danger of the thing switching off at an inopportune moment, shall we say. When you power the unit on, it's in its auto mode. We can see the needle there flicking between volts, ohms and continuity. If we now connect up our leads, touching the two together there, it's flicked immediately into the continuity mode, and we get the continuity buzzer. Bringing in the battery then, as soon as we connect the voltage there, we can see that the meter has flicked onto the voltage range and giving us our 11.57 volts for this little LiPo. If you want to select a particular range, just a question of pressing the auto button, DC/AC volts, ohms there, the continuity test that we've seen. You can see as we flick through the different options here that we get the indicator lights flashing as to where to connect our component for testing. Clicking the function key once again then takes us to the diode test. Now, being the consummate pack rat that I am, I rob components from various equipment, and it's always a good idea to check that these are actually functional. There we can see then the forward volt drop of almost 0.6 volts, which is totally correct for the diode. Positive lead on the negative there. And reversing the leads clearly will be open circuit. Another thing you can do on the diode range quite often, this is a pack of LEDs that came from an Arduino kit. There is no data supplied with them to tell you what the forward voltage drop is. Connecting our positive lead to the longest lead on the LED, then it's lighting up there and we can see that its forward voltage drop is 2.6 volts. Now we can use that value to work out what current limiting resistor we're going to need for any particular voltage. Very handy. Moving along to the capacitance check now then. Again, a drawer full of components of unknown origins. This one then marked at 224J 400 volts. By the way, if you can hear some strange rattling noises going on in the background, do not adjust your set. That is my 3D printer. There we can see then that it is in fact 225 nanofarads. Here we have a little tantalum capacitor. So we know that that is 52 nanofarads, marked as 47. So it's not a very high tolerance component. Finally then, a big guy here, 1500 microfarads. You do have to wait for the capacitor to get charged up, especially on these high value caps. And there we can see it 1.47 millifarads, or 1468 microfarads. We have a range for millivolts, self-explanatory there, and frequency. Check the frequency of your mains should you feel the urge. The next range then is the temperature. When we select the temperature, it gives us Fahrenheit at the top there and centigrade at the bottom. It is fairly chilly in my workshop right now. We connect up the external probe. Let's check the temperature of my soldering iron here. Settling down there at 330 degrees C, more or less. I can hear the magnastat switching in and out to maintain that temperature. In the next section, we'll take a look at the non-contact voltage detector. I think I'm going to find the non-contact voltage detection quite a useful feature. Where I live in the south of Spain, things like health and safety and the difference between live and neutral are rather vague concepts. I was asked to investigate why something wasn't working in an outside pump room, to find that ordinary mains wiring strung along the ground for some 100 meters, and at some point a rodent had a good old chew on it. It wasn't until it rained that the whole thing shorted out. Being able to go along a cable and find a fault, even when it's not as obvious as this one, has got to be useful. On the NCU range then, now please don't try this at home. I'm going to make these wires live, which I have just done, and you saw the meter briefly detect something. If I bring it near to the wires now, we can see the red light has come on, which is indicating a high voltage. If I bring it near to the black wire, it's showing a green and a L for the low voltage. That should then be the neutral wire. As I now move it along the wire, see at that point there it's dropped to a low voltage, and then to a high voltage. If I now disconnect the power, I can reveal to you that the wire is in fact broken at that point. I broke that deliberately, obviously for the purposes of this demonstration. Now I have a dangerously, presumably live wire on the bench here. The other function that it has, if we hit select, it's now looking for live and it's flashing the indicator here. If I now then connect a probe to that wire and make my system live again, we can see that by touching the wire there, it is showing it is hot or high voltage, and it is indeed the live cable. And again, I stress, do not try this at home. If I touch the probe to the neutral wire, it indicates nothing. So this red wire, which should be live, in fact is. That's a good result. Our next selection then is milliamps. When we put it onto the milliamps, it flashes the connections that we need and tells us to connect our leads. So the positive will go there and the negative there. One way to test coin cells and or indeed LEDs is just to put the LED straight across the coin cell. The internal resistance of the coin cell means that it's inherently current limiting. At the top surface then is the positive, and that goes on the longest lead of the LED, which will make this positive. I'll put this on the battery negative, and we can see it's drawing there around about 7 milliamps. Nice and straightforward. Our final range then will be amps. Again, selecting the amps indicates the connections that we're going to need. For this test, I'm going to be using this little car battery and a couple of old headlight bulbs. Negative side of the battery then is going to the bulbs. The other side of the bulbs then will go to the negative on the meter. Positive on the meter will go to the positive of the battery. Now then, if I connect the battery up, we can see it's drawing 3.5 amps. Again, very simple. I've summarised all of the basic functions of the meter. I'm liking it a lot. The nice clear large display is very good. The other thoughtful features like the torch on the back are going to come in very useful. I think this is going to be my daily driver. Also included is a very nice printed manual. Good thing to see these days. If you need the electronic version, I'll leave a link down in the description to the Kaiweets website where you can get all the information that you need. Finally then, I'd like to thank Jenna at Kaiweets for sending me this unit for evaluation. As I said, it's going to become my daily driver. I think you're going to be seeing much more of it. Thanks for watching.